Hey folks, welcome to my channel number pen. So there we have the problem on our screen. If x equals a times theta plus sine theta, y equals a times 1 minus cos theta, prove that at theta equal to pi by 2, y double dash is equal to 1 by a, right? So we have a parametric equation and the parameter here is theta, and we've been asked to prove at theta equal to pi by 2, y double dash equal to 1 by a. And what is your y double dashed? It's nothing but d by dx of dy by dx, right? So let's start off with our dy by dx. And what is our dy by dx for parametric equation? It's nothing but dy by dx equal to dy by d theta divided by dx by d theta, right? Solved these problems in the recent past, and I request you to take a look at some of the videos where I've discussed parametric equations, and I will definitely put a link to one of those videos in the description. So I have dy by d theta divided by dx by d theta. So what is my dy by d theta? I don't think we have a very complex expression, so let me work it out directly. A times dy by d theta is nothing but 1 minus cos theta. So my 1 is on the 0, and then my d by d theta of cos theta is minus sine theta, and therefore I have a minus into minus, therefore my numerator will be 8 times sine theta, right? And when I come to my denominator, I again have a here. I have a simple application of the sum rule of differentiation, and I get 1 plus cos theta. My a gets cancelled out, and therefore my dy by dx is nothing but sine theta divided by 1 plus cos theta. So what is my sine theta? I have a scope to further simplify this, because remember folks, I have to prove that my y double dashed equals 1 by a at theta equals pi by 2. And therefore, before proceeding to y double dashed, which is my dy by dx of dy by dx, please take a look at the expression to see if there is an opportunity to further simplify. The answer is yes, because my sine theta can be represented as 2 times sine theta by 2 into cos theta by 2, right? And then my denominator, which is a 1 plus cos theta, I know that my cos theta, if I want to represent it using the half angle formula, I know that I can write my cos theta as cos square theta by 2 minus sine square theta by 2, right? And when I write that, I know that I can combine my 1 minus sine square theta by 2. Let me highlight them in, say, green. So the expression in green is 1 minus sine square theta by 2, which I can combine it with cos square theta by 2, and then write this out as 2 sine theta by 2 cos theta by 2, the whole divided by 2 times cos square theta by 2, right? Which is, right? So this is what we have. I move to the next line, and then I write my dy by dx. Post simplification, I know that my cos theta by 2 in the numerator gets cancelled out with cos square theta by 2, and therefore I'm left with a tan of theta by 2, right? So I have a tan of theta by 2, right? And this is where it becomes very important for us to simplify before we jump to d square y by dx square, right? Now you see we have a much simpler expression. So now I go to the next step, and I will have to work out what is my d by dx of dy by dx, right? Because that's my y double dashed. So let me write it down first because I'm going to apply the chain rule to solve this particular problem. So what is my d by dx of dy by dx, right? I'm going to rewrite this as d by d theta, right? Watch me out closely, folks. Of dy by dx into d theta by dx, right? And I hope you folks are with me, right? So in all these problems, right, I know that there will be a tendency to get confused when we are doing second derivatives. But do not get confused. Why? Because your first derivative is nothing but yet another function, right? So let us call it, for example, u, right? So let me call this particular function u. So what are we actually doing? We are actually doing du by dx, right? So your du by dx is nothing but du by d theta into d theta by dx, right? And now you see you should be able to follow this better. So my dy by dx equal to u equals tan theta by 2. And my second derivative, which is y double dashed, is nothing but a du by dx. So du by dx equals du by d theta into d theta by dx, right? And what is my u? My u is nothing but dy by dx, right? And that is how we arrive at this, because there will definitely be a tendency to get confused when you do these problems, trying to find out second and third order derivatives, right? Just treat them as a new function. So I have my d theta by dx into d by d theta of dy by dx, right? So I know that I have an answer to one part already, and which is that part? My d theta by dx, let me highlight it in a specific color, is yellow, is something which I worked out here, right? And the only difference is I worked out dx by d theta. So my d theta by dx is nothing but 1 divided by a times 1 plus cos theta is my d theta by dx, right? So there I have one part of the problem already worked out for me. Into, now I come to this part of the expression. Let me highlight it in green. D by d theta of dy by dx, which is nothing but d by d theta of u, which is your tan theta by 2. Let's highlight it in green, right? So I know that my d by d theta of tan theta from first principles is secant square theta. So what is my d theta of tan theta by 2? I apply chain rule to get 1 by 2 times secant square theta by 2. Right? So this is what we have. Let me highlight this in green as well before we go to the next line and simplify this further. So now I have my y double dashed, which is nothing but my du by dx, right? So I write this down. So this is what I have when I express it in the x by y format. Secant square theta by 2, the whole divided by 2a into 1 plus cos theta, right? Now, going back to the question, we've been asked to prove that at theta equals pi by 2, my y dashed is equal to 1 by a, right? So all that I need to do is substitute my theta as pi by 2, right? So what do I get? At theta equals pi by 2, let's move to the next line. So this is my y dashed at theta equals pi by 2, right? Now we know our trigonometry. My secant square pi by 4 is nothing but My secant of pi by 4 is root 2, and therefore my secant square pi by 4 is nothing but 2. And then I have a 2a in the bottom, and then I have a 1 plus cos of pi by 2. My cos of pi by 2 is a 0, so which means I have a 1 plus 0, which makes it a 1, and I'm left with 2 by 2a, which is 1 by a, right? Therefore, we have proved what we have been asked to. My y double dashed at theta equals pi by 2 is equal to 1 by a, right? And I hope you like my content. Please do subscribe to my channel and support. Thank you.